Okay, this is Mr. Ho. I'm going to work out some of these problems for you from the practice test. So number one, we have convert 16 pi over 3 to degrees. Give the exact answer between 0 and 360, so that's within one circle. First, I'm going to convert this, and I'm going to take my 16 pi over 3, multiply that by 180 degrees over pi. So that's pi radians, and the radians will cancel along with the pi. And I'm also going to reduce the 3 and the 180. That'll give me 60. So when I multiply that out, I'll get 16 times 60, which will be 960 degrees. Well, that's not within one circle, so I'm going to have to unwrap that by subtracting 360 degrees, and I'll get 600. That's still too big, so I'm going to subtract 360 again and get 240, and then that should be the answer here. Number two, convert 1.5 radians to revolutions. So I have 1.75 radians, and I'm going to multiply that by for every revolution there's 2 pi radians. So I'm going to put 1 revolution is equal to 2 pi radians. So now my radians cancel, and I'm left with revolutions. And when I divide 1.75 by 2 pi, I get 0.279 revolutions. Number three, find the reference angle. Okay, so I have 6 pi over 7. Well, on the coordinate plane, I know that this is 1 pi. 1 pi is really 7 pi over 7. So I know 6 pi over 7 should be somewhere around here. So 6 pi over 7. So this little reference angle in here will be the difference between 7 pi over 7 and 6 pi over 7, which is 1 pi over 7. Find the principal angle of 900 degrees. 900. Principal angle is within one circle. I'm kind of doing what we did up here in number one, so we're going to subtract 360 until we can get to something reasonable within one circle. And if I do that enough times, I'm going to have to do it like, I believe probably 6, 5, 40, and then that'll give me 180. So 180 is less than 360, so that's my answer right there. So I had to unwrap it twice. Number 5. Give the general form of 900. First we're going to find the principal angle, and we found the principal angle from number 4, so that'll be 180 plus, and then this is a whole circle, which is 360 degrees times number of times we go around the circle. Make sure these units match. This is in degrees, that has to be in degrees. If this was 180 was in radians, which is 1 pi, then you're going to have to add 2 pi, and that would be in radians, but since this is in degrees, we want this answer here. Number 6, give all coterminal angles to 12 degrees if the domains between a negative circle and 2, let's see, I believe that's 3 positive circles. So I'm going to take my 12 degrees, I'm going to add 360, and that's going to give me 480. That's my first one. That's one answer. This is, there are 3. And then I'm going to add 480 again, 360 again, until I go past this number here. So I'm going to get that's 840, and that's my second answer. I add 360 again, I'm going to get 1200, so that's too much. So that's too big, so I don't want that one. But now I have to go the other way. So now I have 12 minus 360. And that's going to give me, remember you have to put the bigger number on top. And then we're going to add a 12 to a negative 360. So we're going to have to borrow. It's a 5, 4, and let's be 348, negative 348 degrees. So there are my three answers. Okay. Number 7. I lied here. There are only 2. Okay. So you have pi over 8, and then you're going to add 2 pi, or 1 full circle. We're going to wrap it around. So we're going to add 2 pi, which is really 16 pi over 8 with a common denominator. So that'll give me 17 pi over 8. That's one answer. And if I add it again, 16 pi over 8, that's going to give me 33 pi over 8. And that's too far because 4 pi is really 32 pi over 8, right? That's 4 pi, so this has gone too far. So I have this one, and then we're going to go negative. So we're going to go pi over 8 minus 16 pi over 8, and I get negative 15 pi over 8. So there are my 2 answers. Number 8. We have a principal angle of 11 pi over 3. Give 2 rotations. So I'm going to use that general form. Here's my principal angle plus 2 rotations clockwise. That's positive. It was counterclockwise is positive. If it said clockwise, it would be negative. So I want 2 pi times 2, which is going to be 11 pi over 3 plus 4 pi. Well, 4 pi with a common denominator would be 4 times 3 is 12 pi over 3. That's my 4 pi here. So that would give me 23 pi over 3. Okay, on this one, let's go down here and draw my positive 5 and a negative 8. So here's 5, here's negative 8. So there's my point down here, and draw that out and straight back up. So this is 5 over here, and this is negative 8. So my hypotenuse will be 64 plus 25, and that's going to be 89. So radical 89 is my hypotenuse. So now with that triangle drawn, I can do all these here. So sine is going to be opposite, which is negative 8 over radical 89, and secant is the reciprocal of that, so that's rad 89 over negative 8. Doesn't matter where I put that negative sign as long as it's in front of the fraction. Cosine is going to be 5 over radical 89. Oops. That's a 9. And then this will be radical 89 over 5. Tangent will just be opposite over adjacent, and cotangent is adjacent over opposite. You find the reference angle. Out of these, this is the easiest one for me to put in my calculator, so I'm going to use tangent of negative 8 over 5. Reference angles are always positive, so I take the absolute value of that. And right now my calculator is in radian mode, so when I put that in my calculator, I get 1.012 radians. Doing my little conversion here, multiplying this by 180 degrees over pi, I get 57.994 degrees. So those are my answers there. Now if this was 57.994 degrees, the angle in standard position will go all the way around this way. So I want 360 minus my 57.994 degrees. And that will give me 3 302.005 degrees. When you convert that to radians, it will be 5.271 radians by multiplying this by pi over 180. Number 12, a circle with a radius of 10 and a central angle of 210. So I want to find the arc length, which I'm going to use S, is r theta. This has been radians, and I don't have radians, so I'm going to convert that. So my arc length will be equal to the radius, which is 10 centimeters, times 210, and I need to convert that, so pi over 180. And then when I put all that in my calculator, I get 36.651 centimeters. Find the area of the shaded region. I don't remember a whole lot of formulas, so I'm going to take the part of the circle, part over the whole. Okay, so I have degrees over degrees. The whole circle is 360 degrees. And then that's going to be my part, the shaded part, the area of the part that I want, over the area of the whole circle. Area of a whole circle is pi r squared, pi r squared. Okay, and then solving for doing a little algebra here, multiplying both sides by pi r squared. I cancel this and multiply it on that side, so the area is equal to 210 over 360 times pi r squared, and I get that is approximately 183.259 centimeters squared. Number 14, give the quadrant which theta lies. Sine is negative. Remember, all students take calculus. Okay. Okay, so sine's negative here and here in 3 and 4, and secant, which is the reciprocal of cosine, is negative. Okay, cosine is negative here and here, so we're in quadrant 3. Number 15, tangent is negative, so tangent is negative would be in 2 and 4, but sine's positive. Well, sine's positive is in 2, so we're going to draw number 15 in quadrant 2, coming out this way. Oops. And then we're going to put the 12. The 12 is going to be this one here, and the 9 is going up. 12 is going to the left. That's why the 12 gets the negative. The hypotenuse is always positive, so this will be 12 squared plus 9 squared. That'll give me square root of 225, which is 15. All right, now I have cotangent. I'm going to write it this way. I'm out of room on this side. This cotangent is the reverse, or the reciprocal of that. So and that reduces to 3/4. This really is 4/3. And then a sine will be opposite over hypotenuse, which reduces. And then this cosecant is a reciprocal of that. And then cosine is adjacent over hypotenuse, and that reduces to negative 4/5. and take the reciprocal of that. Okay. All right, number 16. A circular saw blade. Did one like this in your homework. Ooh, that's okay. Circular saw blade with a diameter of 8 inches and makes a complete revolution in one second. So 12 revolutions per second. All right, so calculate the angular speed. So we don't need to know how big the blade is. We just need to take the 12 revolutions per second, and then we want to end up with degrees per minute. All right, so I'm going to convert my seconds to minutes. 60 seconds over 1 minute. The seconds are on top to cancel that. And then I have to convert the revolutions to degrees. I know that one revolution one time around is 360 degrees. So now I have my degrees. I get rid of my revolutions, degrees per minute. I'm done. I'm just going to multiply 12 times 60 times 360, and I get 259,200 degrees per minute. Now calculate the linear speed. Now we're going to do it again, except now I do need the radius or the diameter. Okay, in the diameter, let's get that in, that's already in seconds, so we're good. And we're going to need 12 revolution. Oh, okay, so one circle is the circumference. The circumference is pi d, and this is in my units here would be in inches per revolution, right? One circle around is 1 revolution, and this will be in inches. So I'm going to have pi times the diameter in inches per revolution. So now my revolutions cancel. Now all I have to do is convert my inches to feet. So I have 1 foot is equal to 12 inches. The inches cancel, and I think 12 cancels, 12, and then I have 8 pi feet per second is what they asked for up here. So that's good. Okay, if you multiply 8 times 3.14, you're going to get 25.133 feet per second, which is also an acceptable answer, but this is rounded and this is the exact. Okay, the Earth is 6,370 kilometers, and then the satellites orbiting the Earth at 300 kilometers above, making the radius of the satellite, some of those, so it'll be 6,670 kilometers. That's the radius. And we're going to take 1 revolution every 100 minutes. We're going to multiply that by, we want this in radians per second. So we want radians per second. So we're going to change my minutes. 1 minute is equal to 60 seconds. Those cancel. Now I need revolutions to radians. And that is going to be, I need 2 pi radians per revolution. And since we're looking for angular speed, we didn't even need the radius. So once you do that, you're going to get radians per second. And when you finish, you should get 0.001047 radians per second. Or your calculator will probably give it to you in scientific notation like this, times 10 to the negative 3. Okay, that's it.